Okay, so today we are going to talk about Avogadro's number. So we're going to title today's notes Avogadro's number. And we know what a number is, but does anybody know what Avogadro is? Okay, well, let's start there. Amadeus Avogadro was an Italian scientist. He was also a nobleman. Okay, baby. Okay, he was an Italian nobleman, and he was very interested in atoms. He created or found a way to, and I'm going to put in quotes, count, sort of, we'll talk about that, count atoms. Okay, so where does this come from? Why are we talking about this? How did we get here? If we remember the dot art that we did, the pointillism piece with the alien spaceship picture, pointillism, lots of dots, make a picture. Okay, then we talked about the penny. Remember our penny friend? The penny had lots of atoms. How did we figure out how many atoms the penny had? Well, that come a lot from Amadeus Avogadro's work. Okay. So remember we said it was 20 hexillion. It's a lot. Well, how did he figure this out? He figured this out by weighing the masses of known atoms. So we'll go ahead and put that up here with Amadeus. He worked with known elements. So we knew, for instance, carbon was an element, and he could identify it and find it and just use it. He knew gases, oxygen, we can find just oxygen, we can find, okay? So what is this number? Okay, let's come back to Avogadro's number. We knew that this 20 hexillion was 20, and we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. That's a lot. Well, Avogadro's number is very close to that. Okay? So let's write it down. Avogadro's number is 6.022 times 10 to the 23rd. So how many of you remember scientific notation? Okay, well, let's kind of go through that. Let's discuss it. That, just like we had this 20 hexillion, if you remember from the reading, it was 2.0 times 10 to the 22nd in the text. So Avogadro's number is 6022, and we got 1, 2, 3. So we're going to move this decimal place 23 times to review. We'll come back to scientific notation later on in the year. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Shoo! I wish I had that many dollars. But remember we said that was more dollars than were in all of the world. So that would not be possible. So we have hundreds, thousands, millions, billions, trillions, quadrillions, pentillions, 602 hexillions. That's a big number. When we look at this number, what does it even mean? This is a count of atoms. This is a number or count of atoms or things. We'll redo a reading here in a little bit and we will learn about. And we could use Avogadro's number to count lots of things, but most of the time we use it to count atoms and molecules. So let's think just for a second, make sure we really understand. If 12 is a dozen, so I can go buy a dozen eggs, right? 144 is a gross, so I can order a gross of those toys, like from Oriental Trading. Alright, a baker's dozen is 13. Then 6.022 times 10 to the 23rd, because I don't want to write all them zeros, is Avogadro's number. There's another word for this too. Of course, science always has a bunch of extra stuff. Avogadro's number also is called a mole. So not the little furry thing that digs in the ground in this class, but a mole. So 12 is a dozen, 144 is a gross, 6.022 times 10 to the 23rd is a mole. It's a count. It is a number of things. It is an amount. So we want to be mindful of that. And let's kind of think about what we just said. If Amadeus Avogadro worked with known elements and he figured out that this number is how many atoms is in that known elements, let's put that together. Okay, so let's make a statement. We're going to say, so scientists and students, scientists can measure a certain mass of known elements or chemicals here, okay, honey. Elements or chemicals, and they know about how many atoms that they have. Okay, so today we're just kind of introducing this word. We're going to come back and use it a whole bunch of times later on in the year. But the idea that you understand Avogadro's number is a count. It is an amount of things, most of the time atoms, compounds. Okay, 12 is a dozen, 144 is a gross, 6.022 times 10 to the 23 is a mole, is Avogadro's number. So it's a number of something, a count, right? That's the big takeaway from this.